This morning I'm going to be demoing a couple of Grails plugins that were developed as part of the ETS Event Data Storage and Retrieval System. The first is called the Cassandra Astonics plugin. It's a simple plugin that wraps the Astonics Cassandra Java client in a Grails service. In Greek mythology, Astonics was the son of Hector, who was the sister of Cassandra. In software engineering, of course, Cassandra is a NoSQL data store we've been using for some time. Hector is one of the first Java clients for Cassandra, and Astonics is a newer client developed by Netflix that makes the interface a bit simpler and has better management tools for failover and redundancy. Netflix is a big user of Cassandra. They have something like 55 clusters at last count, which range in size from 6 to 48 nodes. For comparison, our current Cassandra cluster is 8 nodes, and we have one. We'll soon have 3, but of still somewhat smaller size. The second plugin is called the Cassandra ORM plugin. It's a little bit misnamed because it's not really object relational mapping, but it's makes it easy to store Java or Groovy objects in Cassandra. And that's what I'm going to be showing today. So we're going to start out by creating a simple Groovy class. We're going to call it the user class. We'll start off with just a couple of properties, email address, and name of the user. We need to tell Cassandra how we're going to be mapping this data, so we're going to do this with a way that's similar to but not the same as the built-in ORM system that's part of Grails. So in this case, we're to create a Cassandra mapping object. We do have to specify the primary key. We don't want to generate an ID as you would with a MySQL database. This is often some sort of universally unique identifier, but in this case we're going to make it a kind of native natural key. So there's our class. In order to store this into Cassandra, we do something like this. We're going to create a new user, specify the email address and name, and save it, and that's basically all there is to it. If we go up here to look at the Cassandra CQL prompt, we can do a select star from user, and there we can see our user that we just created. It's in Cassandra. If we want to get this user back from Java, that's also quite easy. We'll do that now. We're just going to get based on the primary key, and you can see we just retrieved our user. Now, of course, this is kind of nice, but one of the main reasons we use Cassandra is for its schemaless nature. So what if we want to store a whole bunch of different things in our user and we don't know what they all are ahead of time? We can do that by creating a data map and call it anything we want. We can tell the system what the name of that map is. It's actually a map, but we use a groovy term, expando. We call this the expando map. We give it that name, and that's pretty much it. Now, if we want to store some other things, we can still come back and retrieve our same user object. Here we can set some properties, my favorite color, and what I'm planning to do next week. Kind of looking forward to that. And oops, don't need to save it. We're going to store that, and now if we go back and run our SQL query, you can see that we've got those additional columns of Cassandra. Now, so we can see how we can write data in, read data out. If we go and we look at the column families that go along with this demo, you can see for the user column family that I defined what's called a Cassandra secondary index on a field called state. And so we can make use of this in this way. We'll add a state field, and we'll declare in the mapping a secondary index on that field. So now we need to we need to set the state on our user, and to make things interesting, we'll add a few more users with additional states. Here's some, I've kind of picked some people from the Virginia office there. So we'll write that. So we've written this data in. If we go back and run our query here, you can see we have a bunch of users. Now is where it gets a bit more interesting. If we want to query for those users, we can do something like this. Find all by state, and there you go. If you know a whole much about Cassandra, you'll know, however, that secondary indexes have some real limitations. They don't really, they work okay for something with a relatively small number of values like state, but they don't really work all that well for kind of high cardinality values like phone numbers and so forth. So we'll add a few more properties to our user, and we're going to add a secondary not a secondary index, but we'll add some additional indexes that we explicitly implement. We do this by storing them in the user index column family. So here I've added some more parameters. I've declared a couple of explicit indexes, one on phone number and one on a combination of gender and city in this case. And we need to populate those fields. One thing about Cassandra is that every insert is basically an upsert. There's no notion of not being able to insert, so it's kind of a shorthand here. I can just do new user saves here as long as the primary key is the same. It's going to write that into the same data structure. So I'll do that, write those values. Now I can query on those fields as well. So here I'll just comment that out so you can kind of see those for reference. And so we'll do a query by phone number. You can see there's the matches for that phone number. If we change this to a different number, you see we get someone else. We can also find all by combinations of numbers. So like in this case, I'll find all by state and city, and there you go, found one person. One final thing, and the one most used by ETS, is the concept of counters. Cassandra 1.0, actually since 0.8, had built-in atomic counters, and this is really one of the things that the ETS data store and retrieval makes heavy use of. So we're going to declare some counters here. The explicit indexes let us query for objects. It actually lets us count those objects, but it's going to be something that depends on the number of objects there as far as performance, and so we can do that in a faster way. So let's populate some data here that has a bunch of information, and we'll give you an idea of some counters. So you can hear I've defined a couple of kinds of counters, and so what the system is doing now is storing this information in the user counter column family, and so I can do things like this. So having defined those counters, let's say I want to go in and I want to look at the number of people I have by state. I can do that. Show me the counts I had by state. I can actually, with just a couple counter definitions, do this in a number of ways. I can also count by state and gender, or I can query by state rather, and count by gender. So if I only want to look at people in Virginia, that's going to show me the number of male and female. With that same counter definition, I can also group by city. So that's going to show me the number by city. And finally, depending on how I'm going to consume this data, I can count by more than one of these operations at one time. or these dimensions at one time. So there's broken out by gender and by city. I think we're out of time now. We'll get into more specifics about the actual ETS data store at a later time.